Alright, so we're going to be looking at exponential functions today, and we already kind of started this last class where we just graphed the basic parent function of y equals 2 to the power of x. And so now in today's lessons we're actually going to be manipulating that, but not by anything we don't already know. We're actually still using the concepts h and k. And so when I talk about h and k, there is a generic formula for any kind of exponential where you have y equals a times b to the power of x minus h plus k. And this is where your k, okay, is always going to be your horizontal asymptote. So that's where you're going to be limited. And then your h, so k, think of it as a vertical shift. And then your h value is going to be then your horizontal shift, right? So h is always going to be opposite of what it says. K will stay the same. And h is going to move right or left. So I'm actually going to be using the main points of your graph that you should have graphed, and I've had to redraw this, but I'm going to be using that the y-intercept, right, of original graph is always one above the horizontal asymptote. So it's always going to be one above. And then from there you go up 1 over 1, and then you're going to go up 3 over 2. Okay, so we're going to go up 1 over 1, and then we're going to go up 3 over 2. And so every time I draw my horizontal asymptote, that's how I'm going to be moving. Let's just do a couple examples. So in A, all right, I already know my horizontal asymptote, which stays the same, is -3. So knowing that K is my horizontal asymptote, I'm going to be drawing my line at -3. So go ahead and draw your line. Now, as I said, using what I know about the parent graph, I'm going to be one above, all right, one above the horizontal asymptote, then I'm going to move 1 over 1, and then I'm going to move up 3 over 2. And then I'm just going to draw my line as best I can. And that's kind of what your exponential function is going to look like. Now, if I want to talk about domain and range, the domain is not going to change. It will always be -infinity to infinity unless we're looking at a certain type of data where you can't have negative days or negative people or a negative number. Otherwise, your domain is always going to be -infinity to infinity. But your range is going to be where you start with your horizontal asymptote. And remember, it's a parentheses. We're not exactly able to hit that. So it's going to start at a -3, and it's going to go to infinity if it's a growth. And it seems to be a growth rate. So just remember, and maybe make a note, that the first number is your horizontal asymptote, or also your k value, right? It's your last value. So it's going to be your k value to infinity, or it's going to be -infinity to your k value if it is decay. So let's look at letter B. So if I'm looking at letter B, right, I'm looking at my k. This is my k. This is my horizontal. Right, it's my horizontal asymptote. So at a +4, I am drawing my horizontal asymptote right across. Now I start, again, 1 above the horizontal asymptote. I go up 1 over 1, then I go up 3 over 2. And I can just draw my graph. Now, what did I say will always stay the same? Well, that's going to be your domain and range. So, well, not your range, but your domain. Your domain is going to be -infinity to infinity, right? There's no limited x values. And then your range value, well, where's my horizontal asymptote? Well, it's at the value of 4. So I'm going from 4 to infinity, right? It's my horizontal asymptote. It's my k value. So let's look at letter C. Letter C, well, if I'm looking at it, what is my K value? And my K value is a -1. So I know this is going to be my horizontal asymptote, and it's going to be starting at -1. So let's go ahead and draw a horizontal asymptote right there. So it's -1. Now, as I said, once I draw my horizontal asymptote, I'm going to be starting 1 above that. And then I'm going to go up 1 over 1 and do my other dot, and then up 3 over 2 and draw my other dot. So, oh, that's not really pretty. Let's make that a little bit better. So I'm gonna have that, I don't know, that didn't really get any better. So draw a better graph than I did. But what should never change? My domain, which will be -infinity to infinity. And then my range is where my horizontal asymptote, right, starts, which is at -1. So my range is at -1 to infinity. So maybe make a little bit of a note here. And the note I would make is domain is never going to change. So domain will always, right, it's going to always be -infinity to infinity unless instructed otherwise by data. Your range, that's what's going to change. It will be a K value to infinity if and only if your graph is growing. So your range will be K to infinity if your graph is growth. However, if your graph is decay, so growth is going up like that, right? Decay is where it's going down, right? This is decay. If your graph is in decay, then you actually start -infinity to your value K. So I would write this little memo down to be able to remember, okay, growth is going to start with your K value, and then when you have decay, it will end with your decay value. So let's go ahead and turn the page. Okay, now that I don't need all these ranges because I wrote it out already, go ahead and cross those out. Let's look at when we have a number in the exponent and when we go back to the original equation, right? If we go back looking at the original equation, we have y equals a times b to the x minus h plus k. So now that I don't actually have a k here, right, my k equals 0. That means my horizontal asymptote is going to be 0. So if I want to go ahead and graph that, it's going to be 0. And then what ends up happening is, well, my h is how it shifts, right? And remember, h is always opposite. So if h is opposite, and I have a -3 here, that means I'm going to shift 3 to the right, right? It's going to be a +3. So if I shift 3 to the right, then I'm 1 above my horizontal asymptote, and I start right here, and then I go up 1 over 1, and then go up 3 over 2. And then you can just draw as best you can, better than me, hopefully, what your graph is supposed to look like. It is supposed to go through all the dots. But let's remind ourselves what domain is. Domain is the same, -infinity to infinity. You can almost copy and paste to all the domains. And again, your range is where since it's growth, it's going from your k value, which is 0, to infinity. That would be your domain and range. Let's look at letter E. Letter E, I don't see a k, right? So if I don't see a k, my horizontal asymptote is 0 again. But how am I shifting this time? Well, I have a +4. So that means, right, I'm going to the left 4. So let's go to the left 4. And because of where my horizontal asymptote is, I'm going to go above 1. Then I'm going to go up 1 over 1 and up 3 over 2. And here is your graph. Now, domain, copy and paste. Domain should be copy and paste. It's -infinity to infinity. And then your range is where your horizontal asymptote starts, so it's 0 to infinity. Let's try one more where it's just focusing on h. Now I don't see a k equaling 0. That means my horizontal asymptote is at 0. So let's go and draw that. Then, well, how am I shifting? I'm shifting to the right one because it's the opposite. So at right 1, I start 1 above, go up 1, over 1. There's my other dot. Then go up 3 and then over 2. It's my third dot. Oh, I'm getting better at this. Okay, so then go ahead and graph your graph. Draw your graph through the points more successfully. I didn't want to do that. More successfully than I did, hopefully. And again, domain, copy and paste, and range is about copy and paste now. My horizontal asymptote is at 0, so I will be going from 0 to a positive infinity. All right, now that we've conquered both our h's and our k's, let's kind of combine them. And it really doesn't get any more difficult than this. I first want to look at my k value, right? And my k value is a -2. So this is where my horizontal asymptote will be. So I'm starting at a -2. All right, going down there. And then, well, how does my h shift my starting point? And it shifts it to the left 3, right? It's a positive 3, so that means I'm going to the left. So I'm shifting to the left 3. So looking at where my horizontal asymptote is, right? It's at -2. I'm only starting above that, but I'm shifting to the left 3. So I'm starting 1 above it, but I will be at -3. So then I go up 1 over 1, then I go up 3 over 2. And here's your new graph. All right, copy and paste. Domain and range. Well, not necessarily range, but domain at least is copy and paste. -infinity to infinity, right? My range is growth, so it's going to start with my k value, which is -2, and it goes to positive infinity. All right, letter H. Letter H is starting where? Well, our horizontal asymptote, right, is at a +1. So let's just draw that. All right, that's our first kind of step we want to do is draw our horizontal asymptote. Then I am looking, okay, I'm going to be looking at, well, how am I shifting my graph left or right? And this seems to be to the right 2. So I'm going to be starting at a +2. But I'm starting 1 above the horizontal asymptote. So then I go up 1 over 1, and then up 3 over 2. So go ahead and draw your graph through your points. All right, domain and range, copy and paste. Domain, -infinity to infinity. That is a terrible infinity sign. Let's change that. There we go. And then range. Range is going to be your k value, which is a +1 all the way to a positive infinity. All right, lastly, letter I. If I'm looking at letter I start at a -3. This is my horizontal asymptote. And then I am shifting what? Well, it's a -4, so that means I'm shifting to the right 4. So let's go ahead and draw my horizontal asymptote on my graph at -3, which is right there, all the way across, straight as you can, kind of as dashed. And then, if I'm going to the right 4, I'm starting, here's my right 4, right there. And then what I want to do is just start 1 above the horizontal asymptote, right above that line, and then go up 1 over 1, and then go up 3 over 2. And then go ahead and connect my points into a exponential graph. So let's just write our domain and range. And so our domain is copy and paste. It is -infinity to infinity. And then when we are looking at our range, well, what's my k value? It is -3 and it is growth. So it means I'm starting with my k value. So I'm going to go from -3 to a positive infinity, and that is my range. All right, I would ask for any questions, but clearly I am not there to answer them. So what I want you guys to do is go ahead and turn the page. You do not need to pay attention to these boxes as of yet, so go ahead and if you want, cross them out. And then we are going to be, I will do a couple examples of review for you, and then you will be on your own to work on review and homework. So looking at number 3, the first thing I should realize that there is a division sign. So looking at this division sign means I'm going to have to flip it, and I probably want to factor these two things. So first, this is a special factor. This is x and x, and then 4 and 4. So I'm going to have sum and difference of x plus 4 and x minus 4 all over x plus 4. You should see something that you might want to do. And then I have to flip these. So when I flip these, I'm going to have an x minus 1 on top. But let's go ahead and factor this equation. So I'm going to have a negative 20 on top and then a positive 1 on the bottom. And the two factors that would multiply to a negative 20 that add to a positive 1 are a positive 5 and a negative 4. So I'm going to have on the bottom x plus 5 and x minus 4. Now, you might want to see what you can do from here, but I would actually start simplifying by crossing things off. I have 2 x minus 4s and I have 2 x plus 4s. So I'm left with x minus 1 over x plus 5 as my final answer. Alright, let's move to B. B is kind of fun. So with B, I'm adding two fractions, meaning I have to get them to the same denominator, and they're clearly not the same denominator. If I want to factor this, it's a sum and difference, so it's x plus 3 and x minus 3. And then I have to find the missing term. So the missing term for the second one, I have an x minus 3, but what I am actually missing is an x plus 3. So I'm going to times it by a fancy 1. So it's x plus 3 over x plus 3. And then what I'm going to do is I'm going to simplify everything. So I have 2x, and then I am going to have that over x plus 3 times x minus 3 plus, and I'm going to distribute. So I'm going to do 5 times x, which is 5x, and then 5 times 3, which is a positive 15, all over x plus 3 times x minus 3. And now I can kind of combine the tops. So 2x plus 5x is going to be 7x, and I can't combine 15, all over x plus 3 times x minus 3. And there's nothing else I can do. 7 is prime, so that's as simplified as that can get. Alright, let's try number 4. So number 4, solve for the following equations. I see two single fractions equaling each other. That means my instinct should go to cross multiplying. Well, I'll do x minus 2 times x plus 3. So I'm going to have x minus 2 times x plus 3, and then that equals another cross multiple, so it's x plus 4 times x plus 1. Alright, then I have to FOIL out x times x. Well, it's going to be x squared. X times 3 is 3x, 2 times x, which is, or negative 2 times x, which is negative 2x, and then negative 2 times 3, which is negative 6. Then do it again. X times x squared, x times 1, x times 4, 4x, and then lastly 4 times 1, which is 4. Alright, so now what I can do is, what if I subtract x squared from each side? They cancel out, and let's combine some terms. So I'm looking at the x's, which I can combine. So I'm going to get just a positive x over here, and I'm going to get a 5x on this side. So I end up with x minus 6 equals 5x plus 4. So what I can do is, let's subtract 5x from each side. So then I'm going to be left with negative 4x minus 6 equals a positive 4. And let's just add 6 to each side. So then I'm left with negative 4x equals a positive 10. Well, how do I get x alone? Divide by the coefficient of x, which is negative 4. So simplified, x equals negative 5 over 2. If you keep 10 over negative 4, that's fine, but probably on a test you're going to see negative 5 over 2. And that is your final answer for that one. All right, lastly, so then we can move on and you guys can get to homework. Okay, so lastly, I have 2 fractions on one side and 1 fraction on the other, so that doesn't mean I can cross multiply. What I want to do is simplify by multiplying everything by the common denominator, which I can find. First, let's factor this one. So if we factor that into diamond, I have a 6 and a negative 7, 2 things that multiply to a positive 6, but add to negative 7 is negative 1 and negative 6. So if I want to cross that out to x minus 6 times x minus 1, or if you switch them, that's fine. But the common denominator now is x minus 6 times x plus, not plus, but indeed minus 1. Alright, so now I want to multiply everything by that common denominator. So when I multiply, I'm going to have x minus 6 times x minus 1, and then x minus 6, minus, then x minus 1, and then x minus 6 again, and then x minus 1, and cross out what I can. So whatever I have on the bottom, I can cross out on the top. So x minus 1, x minus 1, x minus 6, x minus 6, and then I can end up crossing out the whole entire thing. So when I distribute, I get 3x times x, which is 3x squared, and then 3, not all the way over there, but 3x times negative 6, which is negative 18x, then plus 2x times x, which is 2x squared, and then 2x times negative 1, which is negative 2x. Alright, so I'm left with, on the other side, just 5x squared minus 15x plus 20. Alright, let's simplify some things. I have a negative 2x, negative 18x, and a 2x squared and 3x squared. So it gives me 5x squared minus 20x equals 5x squared minus 15x plus 20. Alright, let's subtract my 5x squared from each side, which ends up completely canceling out all my x squareds. So I'm left with negative 20x equals negative 15x plus 20. Alright, let's simplify this more. Let's get all the x's to one side. I can easily do that. Let's add some 15x's, you know, it's the opposite of subtraction. So I have negative 5x equals a positive 20. Well, now to get x alone, let's just divide it by the coefficient, which is negative 5. 20 divided by negative 5 is negative 4. So x equals negative 4, and that is your complete answer. So just remember, if you have any questions, the note keys are actually online, and so is this lecture. So you can always rewatch it, and also email me if you have questions.